Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and today I'm going to solve some past paper questions from International A-Level Edexcel P1. The topic is trigonometry, basic trigonometry, trigonometric ratios. Okay, and we have a past paper handout over here, and this is question number 4 of the handout, which is January 2008. C2 question number 6. This particular subtopic of trigonometry was earlier tested in C2, the old specification UK C2 paper. Okay, and now this is since the introduction of International A-Level at Excel P1, this particular subtopic is now tested in P1 Pure Mathematics 1. So let's start with this question. Okay, so it says that it shows three yachts A, B, and C, which are assumed to be in the same horizontal plane. Yacht B is 500 meter due north of yacht A. Okay, so from A, so if you make a north at point A, so this yacht B is basically due north of point A, meaning point B is vertically upwards from point A at a distance of 500 meter, as simple as that. And then it says that the yacht C is 700 meter from A. All right, so the distance between point C and point A is also given. And then it continues to say that the bearing of C from A is 015 degrees, meaning if you make a north at point A, okay, so you have an angle of 15 degree in clockwise path because this is a bearing. Okay, after the word from, whatever you have the alphabet, at that particular point you make a north. Okay, so this bearing is 15 degrees over here. So requirement of part A is to calculate the distance between yacht B and yacht C in meters correct to 3SF. Okay, we need to find the distance between B and C. All right, so first of all, what we are going to do, we are going to consider this triangle ABC. All right, so as we can see that, this angle is 15 degrees over here, and the length which is opposite to this 15 is BC. So what we are going to do, we are going to use the cosine rule, okay, because this length AC is given to us, this length AB is given to us, and the included angle is given to us. So if I use the cosine rule, I can make the formula in this way that BC square is equals to AB square plus AC square minus 2 times AB times AC multiplied by cos A. Okay, in this way, I've made the formula over here. So I can say that BC square is equals to 500 square plus 700 square minus 2 times 500 times 700 times cos 15 degrees. Okay, so we are just going to evaluate the value of BC square over here. So just put this complete thing in your calculator. 500 square plus 700 square minus 2 times 500 times 700 multiplied by cos 15. Make sure that your calculator is in degree mode because the angle is given in degrees. So this turns out to be 63851.9216. BC square is 63851.9216. So BC is basically the under root of this value, under root of 63851.9216. So under root of this answer is basically 252.689. So 252.689, and we need to give our answer correct to three significant figures. So therefore, the length of BC is 253 meter correct to 3SF. Okay, this is the requirement of part A. After this, we have part B. which says that the bearing of yacht C from yacht B is theta degrees. Okay, as we can see in the sketch over here. If we make a north at point B, so the angle which is in clockwise path is theta degrees. This tells you the bearing. So what we need to do, we need to calculate the value of theta. And as we can see that, you know, this theta is obviously an acute angle, because if you consider this triangle ABC, this angle ABC, which I'm marking right now, is an obtuse angle. Makes sense because it is open more than 90 degrees. Okay, so ABC is an obtuse angle, which essentially means that this theta is an acute angle. So our answer theta must be an acute angle. All right. So what we are going to do, first of all, we are going to consider this triangle ABC again. Okay, I'll bring the picture of the triangle again over here. And what we have found the length of BC, which is 252.689 to a higher accuracy. Okay, the answer of part A was 253 meter, but we are going to use this BC length in further calculation. So we have to choose this higher accurate value in order to avoid premature approximations. Okay, so this BC length is 252.689 meters. Okay, so we have to find this obtuse angle first. So what we can do, we can use the sine rule. I can say that sine ABC upon the length is AC. Okay, so the length AC is basically corresponding to the obtuse angle ABC, and this is equals to what? Sine BAC upon this length BC, which we have found in part A. All right. So therefore we can say that sine ABC, or you can just mention sine B. Sine B divided by the length of AC is 700. This is equals to sine 15 divided by the length of BC, which is 252.689 meter. Okay. So as we can see that this angle ABC, which is inside the triangle, this angle is basically obtuse angle. And as we know the fact that when sine is positive, so angle can either be acute and it can be obtuse as well. But in this case, angle ABC is obviously obtuse angle. Okay, so sine B will be equals to 700 multiplied by sine 15 divided by 252.689. Okay, so just find the value of sine B over here. Put this complete thing in your calculator. So put this complete thing in your calculator. 700 sine 15 is divided by 252.689. This turns out to be 0.71698. 0.71698. All right. So therefore, I can say that angle B is equals to sine inverse. I can say that angle B is equals to sine inverse 0.71698. So sine inverse 0.71698. This is supposed to be 45.806 degrees. Okay. If this angle B is acute, then it would be 45.806. But this is an obtuse angle. This angle B, meaning angle ABC, is an obtuse angle. So obviously, we need to subtract this acute angle from 180 degrees, meaning angle B, which is an obtuse angle, in this case is 180 minus 45.806 degrees. Okay, because when sine B is positive value, B can either be acute, it can be obtuse as well. But in this case, obviously, we have an evidence that since this theta angle is acute, so angle ABC is an obtuse angle. All right, this is how you do this. So 180 minus 45.806. This is supposed to be 134.194 degrees. So this obtuse angle B is 134.194 degrees. So therefore, angle theta is supposed to be 180 degrees minus 134.194 degrees. Okay, since if you add this angle ABC and this angle theta, so the sum will be 180 degrees because these are supplementary angles. Okay, angles on a straight line. That's why. So therefore, theta is supposed to be 180 minus 134.194, which is obviously this acute angle, which we found 45.806 degrees. Okay, and therefore we can say that correct to three significant figures, this angle theta is 45.8 degrees. Okay, 45 point, this angle theta is 45.8 degrees. This is supposed to be our answer. All right, this makes sense. Or you can write 46 degrees as well. But since the bearing was not asked, specifically the angle theta was asked, but this angle theta is a bearing. So either you can write your answer as 45.8 degrees or you can say 46 degrees. All right, so this was basically the question number 4 of this handout, which is January 2008 C2 question number 6. So now let's move on to the next questions. So now let's move on to the next question, which is question number 5 of this handout. This is January 2011 C2 question number 2. So the question says that in the triangle ABC, the length of AB is 11 centimeter, BC is 7 centimeter, and the length of CA is 8 centimeter. The requirement of part A is to find the size of angle C, and we need to give our answer in radians correct to three significant figures. Alright, so first thing first, let's make a sketch over here. Making a sketch is not a requirement, but if you make a sketch, things become easier for you to comprehend. So we have a triangle which is ABC, where the length of AB is 11 centimeter, BC is 7 centimeter, and CA is 8 centimeter. And we just need to find the size of the angle C. So we are going to use the cosine rule. So therefore, we are going to say that, AB square is equals to AC square plus BC square minus 2 times AC times BC multiplied by cos C. Okay, so as we can see that 11 square is equals to 8 square plus 7 square minus 2 times 8 times 7 multiplied by cos C. So when we make cos C the subject, so cos C is supposed to be 8 square plus 7 square minus 11 square divided by 2 times 8 times 7. Okay, so cos C is equals to how much? Just evaluate this complete thing. 8 square plus 7 square minus 11 square. So in the numerator you have minus 8. Okay, and divided by 2 times 8 times 7. This is 112. And since the value of cos C is minus 8 divided by 112, obviously this would be an obtuse angle. Okay, so this sketch is just a rough sketch. It is not up to the mark, not up to the scale. As you can see that from this sketch, you can see an acute angle, but since the value of cos C is minus 8 divided by 112, so obviously angle C is an obtuse angle. But you need to make sure you need to give your answer in radians correct to three significant figures. Okay, so this is the thing. So what I'm going to do, I am going to find the angle C. So therefore, angle C is equals to cos inverse minus 8 divided by 112. Okay, so I'll convert my calculator in radian mode. So cos inverse minus 8 divided by 112. This is supposed to be 1.6423. Angle C is 1.6423. First of all, I'm going to write the angle to a higher accuracy, and then I'm going to give my answer as per the requirement, correct to three significant figures. Therefore, angle C is 1.64 radians. Okay, so this is how you attempt this part. This sketch is not uh, this sketch is not according to scale and not very accurate. Angle C is actually obtuse over here. So this sketch would be something like this, that the triangle ABC is like this, where this angle C is an obtuse angle. AB is the highest length, 11 centimeter, AC is 8 centimeter, and BC is 7 centimeter. All right, so now let's move on to the next part. In part B, it says that find the area of triangle ABC, giving our answer in centimeter square, correct to three significant figures. So for part B, we are going to find the area, and the formula for area is by using the sine rule. The area of triangle ABC would be half into AB into sine C. So according to this sketch, I can say that half into AC length multiplied by BC length multiplied by sine C, where angle C is basically an obtuse angle. Okay, so I can say that half into 8 into 7 multiplied by sine 1.6423. Okay, because I'm using this angle in my further calculations, so I'm going to choose a higher accurate angle over here. All right, so just evaluate this thing. Half multiplied by 8 multiplied by 7, this is 28, and 28 multiplied by sine 1.6423. So 28 multiplied by sine 1.6423, this is supposed to be 27.928, 27.928 centimeters square. Okay, and then I'm going to give my answer correct to three significant figures, which is 27.9 centimeter square. This is supposed to be your answer to part B. All right. So this was basically question number 5 of the handout, which is January 2011, C2, question number 2. All right. So now let's move on to the next question. So now moving on to the next question. Now we have question number 7 of the handout, which is June 2017, C2, question number 2. So it says that in the triangle ABC, the length of AB is 16 centimeter, the length of AC is 13 centimeter, angle ABC is 50 degrees, and angle BCA is X. Find the two possible values for X, giving your answers correct to 1 dp. So first thing first, we are going to make a sketch. All right. So the length of AB is a fixed length 16 centimeter, and the length of AC is also a fixed length 13 centimeter, and angle ABC is a fixed angle which is 50 degrees. Okay. So I'm going to make a sketch like this. Let's say this is point A, this is point B, and we will have two possible positions for point C, because angle C can be acute as well, obtuse as well. That's why we have the requirement to find the two possible values for X. Okay, because angle BCA is basically angle X, which is unknown. So first of all, if this angle BCA is acute, so I'm going to make the sketch over here. All right. So the length of AB is a fixed length, which is 16 centimeter, and the length of AC is 13 centimeter. Okay, and BC length we don't know right now. Okay, and this would not be a fixed length, because if this BC was a fixed length, then uh, how can you say that angle C will have two possible values? Okay, this BC length will change. In this case, this angle C, angle BCA is acute, as you can see over here. Okay, so in this case, I'm going to say that X is acute. And if I want to make another triangle, if I want to make another case where the angle X is obtuse, so I'm going to change the position of this point C. Let's say now point C is somewhere over here. And since the length of AC is 13 centimeter, okay, so the length of AC over here will also be 13 centimeter. Okay, it would look just like an isosceles triangle. Okay, so let me move this point C over here, let's say somewhere over here, so that you would be able to see that the length AC is the same, 13 centimeter, and here you have an isosceles triangle over here, meaning these are the two possible positions of point C. And in this case, I'm going to say that angle BCA is actually obtuse. Okay, so I can say that this is C1 and this one is C2, or the first one was C1 or the second one was C2. That's fine. So I've made one sketch in which I have mentioned these two possible positions of C. Otherwise, you can make two sketches in which one angle is acute and one angle is obtuse. You can also make a sketch like this, that in this case, angle C, meaning angle X, is acute, and in this case, angle C is basically obtuse. All right. So the length of BC, the thing which I'm trying to explain to you is that the length of BC will change according to the different possible values of X. Okay, because AB will remain fixed as per the information in the question. AC will also remain fixed as per the information of the question. And angle ABC is 50 degrees. This will also remain fixed as per the information of the question. Okay, angle ABC is 50 degrees. So the angle which is going to change is angle X. Either it can be acute or it can be obtuse, which essentially means that we have two possible positions of point C. Either point C can be over here or it can be over here. This obviously implies the fact that the length of BC will change according to the two possible values of C. This makes sense or not? Okay, and this AC length is 13 centimeters, so this AC length is also 13 centimeters, such that if you observe this, you will have an isosceles triangle over here. Okay, this AC1, C2. All right, so basically the making of a sketch is not the requirement of the question, but if you make your sketch, things become easier for you to, comprehend, and you can attempt the question. Otherwise, this sketching is not a part of the requirement of the question. You need to just find the two possible values of X. Okay, because the concept behind this is that when sine theta has a positive value, okay, when the value of sine theta is positive, so theta can be acute as well or obtuse as well. All right, it can be either acute or it can be obtuse. So this is basically the whole concept behind this. All right, so what we are going to do, we are going to use the sine rule over here. All right, so I'm going to say that sine B upon 13, meaning AC length. So sine B divided by AC, this is equals to sine C divided by AB length. Okay, so I'm going to say that sine 50 degrees divided by 13, this is equals to sine X divided by 16. Okay, so sine X will be equals to 16 sine 50 divided by 13. So the value of sine x is a positive value. Okay. So just evaluate this thing. So 16 sine 50 divided by 13. The value is 0.94282. 0.94282. Okay. So this means that sine x has a positive value. So angle x can be acute as well. It can be obtuse as well. So x is equals to sine inverse 0.94282. Okay, so if you put this thing in your calculator, sine inverse 0.94282, so you are going to get an acute angle which is 70.531. Angle x is 70.531 if x is acute. Okay, and if x is obtuse, okay, in this case x is acute, and if x is obtuse, okay, so 180 degrees minus, you can say 180 degrees minus 70.531 degrees. So 180 minus 70.531 degrees, this is 109.469. Okay, so you need to give your answers correct to 1 dp. Okay, so therefore x is equals to 70.5. In this case, x is acute, and x is equals to 109.5. In this case, angle x is obtuse. Okay, so 109.5 degrees. In this case, angle x is obtuse. So this is basically the ambiguous case. Ambiguity over here. Angle x can be acute as well. It can be obtuse as well because the value of sine x is positive. When sine theta is positive, so theta can either be acute or it can be obtuse. Okay, so if you don't make a sketch, that's perfectly fine, but just for the sake of some detailed explanation over here, I have made the sketch over here. Either you can put a one complete sketch in which this angle C is acute and in the other case C is obtuse. Otherwise, you can make two sketches like this, whatever feels easy for you. All right, so this was basically question number 7 of the handout, which is June 2017, C2 question number 2. So moving on to the next question, question number 9 of the handout. This is June 2014, C12 question number 1. C12 is basically old specification paper in which the content of P1 and P2, meaning the content of C1 and C2 was combined, and now this specific subtopic is completely tested in P1. So these questions are also good for practice. So the question says that figure 1 shows the position of three stationary fishing boats A, B, and C. Okay, the boats are stationary, meaning they are in rest, okay, which are assumed to be in the same horizontal plane. Boat A is 10 kilometer due north of boat B, and boat C is 8 kilometer on a bearing of 65 degrees from boat B. All right. So the requirement of part A is to find the distance of boat C from boat A, giving your answer correct to the nearest 10 meters. Okay, we need to find the distance between A and C over here. So we are going to find the length of AC, and we know this length AB, this length BC, and the included angle 65 degrees. So we are going to use the cosine rule. So for part A, we are going to use the cosine rule over here. All right. So I'm going to say that AC square is equals to AB square plus BC square minus 2 times AB times BC multiplied by cos B, or you can say cos ABC. Okay, so AC square is equals to the length of AB is 10, so 10 square plus 8 square minus 2 times 10 times 8 multiplied by cos 65 degrees. Okay, so put this complete thing in your calculator. So when we put this complete thing in calculator, 10 square plus 8 square minus 2 times 10 times 8 multiplied by cos 65. So the value of AC square is 96.3811. Okay, so AC is basically the square root of this value. So the square root of 96.3811, this is supposed to be 9.817. So the length of AC, I'm going to write it to a higher degree of accuracy. Okay, the length of AC is 9.817 kilometer, but we need to give our answer correct to the nearest 10 meters as per the requirement of the question. Okay, so this means that I can say that AC length is 9817 meters. Okay, since 1 kilometer has 1000 meters. Okay, and correct to the nearest 10 meters, this is supposed to be 9820 meters. This is supposed to be your answer according to the requirement of the question. All right, so we need to give our answer correct to the nearest 10 meters over here. All right, and if we want to use the same value in the further calculation, the length of AC, so we are going to use this value over here, which is in kilometers. All right, so this was the requirement of part A. So now let's have a look at part B. The requirement of part B is to find the bearing of boat C from boat A, and we need to give our answer correct to 1 dp. So what I'm going to do, I'm going to take the screenshot of this sketch and bring it down so I can use this sketch. Okay. So here we have the sketch, and the requirement is to find the bearing of boat C from boat A. Okay, so this means that at A we need to make a north, which is already over here, and this is the requirement, the bearing of C from A. Okay, and obviously this angle is an obtuse angle because this angle BAC would be an acute angle. All right, this angle BAC inside the triangle would be an acute angle, and the bearing which we are required to find is an obtuse angle, as we can see according to this sketch. And one more thing, the length of AC, I'm going to write it over here according to a higher degree of accuracy. One more thing which I need to tell is that the angle which is opposite to this AC length is 65 degrees. Okay, so as you know that the length of AC is higher than BC, and the length of BC is 8 kilometers. So obviously the angle which is corresponding to this length 8 kilometer would be less than 65 degrees. We can say that this angle BAC is less than 65 degrees. All right, this makes sense. All right, because the angle which is opposite to the length of AC is 65, and since the length of BC is 8 kilometers, which is basically less than the length of AC, so obviously the angle which is corresponding to this length of 8 kilometer would be less than 65 degrees. So obviously angle BAC is supposed to be an acute angle. Okay, I hope these things make sense to all of you. So what we are going to do, first of all, we are going to find this acute angle BAC over here. So I'm going to say that sine A divided by 8 is equals to sine 65 divided by the length of AC, which I'm going to pick to a higher degree of accuracy, which is 9.817 kilometers. Okay. So I'm going to say that sine A is equals to 8 sine 65 divided by 9.817. So just put this thing in your calculator. So sine A is equals to how much? 8 sine 65 divided by 9.817. Okay, so 0.73856. Sine A is equals to 0.73856. All right, and angle A will be equals to sine inverse 0.73856. So angle A is supposed to be, just put this thing in your calculator, sine inverse 0.73856. This is 47.609 degrees. Okay, this angle A is acute, meaning angle BAC is acute, but the bearing is actually obtuse, since you know the fact that the angles on a line, angles on a straight line are supplementary. Their sum is basically 180 degrees. So the bearing, the requirement of the bearing is supposed to be 180 degrees minus 47.609 degrees. Okay, so how much this is? My pen is not working very much smoothly these days. I'm going to rewrite this. Bearing is 180 degrees minus 47.609 degrees. So how much this is? Uh, this is 132.391 degrees. Okay, 132.391 degrees. 132.391 degrees, and correct to 1 dp, 132.4 degrees will be your answer. All right, so this was the requirement of part B. Okay, so this was basically the question number 9 of this handout, which is June 2014 C12 question number 1. Okay, so now moving on to the next question. Now we have question number 12 of the handout, which is January 2018 C12 question number 13. Okay, so the question says that figure 4 shows the position of two stationary boards A and B and a port P, which are assumed to be in the same horizontal plane. Board A is 8.7 kilometer on a bearing of 314 degrees from port P. Okay, so if you make a north at port P, so this is a reflex angle 314 degrees. Okay, so we can easily calculate this acute angle over here, 360 minus 314 degrees. All right, then port B is 3.5 kilometer on a bearing of 52 degrees from port P. So again, if you make a north at P, so this bearing is 52 degrees. Okay, so show that angle APB is 98, meaning the sum of 52 and 360 minus 314. So for just 1 mark, you need to do the working in part A. So first of all, what we know the fact is that this bearing, if you make a north at point P, so this bearing is 314 degrees as per the information of the question. So this acute angle would be 360 minus 314. So 360 minus 314 degree, this is supposed to be 46 degrees. Okay, and what we know the fact is that this angle is 52 degrees. Okay, so therefore we can say that angle APB is 46 degrees plus 52 degrees. Okay, 46 plus 52 degrees. So therefore the value of angle APB is 98 degrees as per the requirement of the question. All right, so this part was just 1 mark. So now in part B, it says that find the distance of boat B from boat A, giving our answer correct to 1 dp. You need to find the length of AB over here. Okay, so what we know the fact is that this length AP is given to you 8.7 kilometer. This length PB is given to you 3.5 kilometer, and the included angle you have already found in part A. So obviously you are going to use the cosine rule over here. Okay, so for part B, I'm going to do the working over here. We are going to use the cosine rule. So AB square is equals to 8.7 square plus 3.5 square minus 2 times 8.7 times 3.5 multiplied by cos 98 degrees. Okay, so just put this complete thing in your calculator. Complete expression 8.7 square plus 3.5 square minus 2 times 8.7 times 3.5 multiplied by cos 98 degrees. So the value is 96.4156. All right, and then we are going to take the square root of this value. So the length of AB is, first I'm going to write to a higher degree of accuracy so that I can use that value in my further calculations in order to avoid premature approximations. So under root of this value is 9.8191. All right, and then according to the requirement of the question, correct to 1 dp, therefore the length of AB is 9.8 kilometers, correct to 1 decimal place. All right, so this was the requirement of part A. Sorry, part B. All right, then we have part C, which says that find the bearing, find the bearing of boat B from boat A, giving our answer to the nearest degree. Okay, so what we are going to do, we are going to use as a sketch. So I'm going to take a screenshot of this sketch and bring the picture down so that we can mark the things over here. So I'll bring the picture on the next page. All right. So what information do we have for part C? Um, what we need to find, we need to find the bearing. We need to find the bearing of boat B from A. Okay. From A means you have to make a north at point A. All right. So here I've made the north, and you need to find the bearing of boat B. All right. So obviously we need to find this angle, which is an obtuse angle. Okay. So what I can do is that I can establish the fact that what we know the fact is that when this angle is 46 degrees, so according to the property of alternate angles, this angle is also 46 degrees, this acute angle. Okay. As you can see that this length, the vertical length at point P and the vertical length at point A, these both are parallel to each other. So obviously this 46 degree and this angle, they are same. So this angle is also 46 degrees according to alternate angles property. Okay, I can say that this angle is 46 degrees according to alternate angles. So I'm going to use this angle 46 in my workings. And what we need to find this angle PAB, which is also an acute angle. All right. As we know the fact that this uh, angle PAB, which is unknown, so the length which is opposite to this angle is 3.5 kilometer. Okay. And the length of AB we have already found in earlier part. What was the length of AB? 9.8 kilometer. Okay, so I'm going to write the value to a higher degree of accuracy if I'm going to use this value in my further calculations. And this complete angle is 46 plus 52. So obviously, this angle is less than 98 degrees. Okay, but we already know the fact that the bearing which we are required to find is an obtuse angle, and the remaining two angles are acute over here. Okay, so that is basically the concept behind this. All right. So what we can do is we can use the cosine rule as well. We can use the sine rule as well. So if I use the sine rule over here, so I can say that sine 98 degrees divided by the length of AB, which is 9.8191, and this is equals to sine PAB, or you can simply say sine A, sine PAB divided by 3.5 kilometers. Okay, so sine PAB is equals to 3.5 multiplied by sine 98 divided by 9.8191. So put this complete thing in your calculator. 3.5 multiplied by sine 98 divided by 9.8191. So this is supposed to be 0.35297. So I'm going to take it 0.35298. Okay. So this is 0.35298. All right. And therefore angle PAB, the acute angle, will come sine inverse 0.35298. So sine inverse 0.35298. This is supposed to be 20.6696 degrees. Okay. So I can say 20.67 degrees. Angle PAB is 20.67 degrees. All right. So in order to find the bearing, the required bearing is supposed to be 180 degrees minus this acute angle PAB 20.67 degrees, and the angle which we found, the alternate angles property, 46 degrees, because the sum of these three angles will be 180 degrees because they are supplementary angles on a straight line. So 180 minus 20.67 minus 46 degrees. This is supposed to be 113.33. So the bearing is 113.33 degrees, and we need to give our answer correct to the nearest degree. So this is 113 degrees. All right. So this was the requirement for part C. Your answer is 113 degrees. All right. So this was basically the question number 9 of handout. Sorry, question 12. Question 12 of the handout, January 2018, C12, question number 13. Okay, so now moving on to the last question of this video. We have question number 13, which is October 2019, C12, question number 7. So it says that figure 2 show the sketch of a triangle ABC. Given that the length of AB is 4x, BC is 3x, and angle BAC is 30 degrees, show that sine ACB is equals to 2 over 3. Very simple. What we can do, we can use the sine rule over here, right? So for part A, I'm going to say that, sine 30 degrees divided by 3x, this is equals to sine ACB divided by 4x, sine ACB divided by 4x. All right. So we are going to say that sine ACB is equals to 4x multiplied by sine 30, and the value of sine 30 is half. So 4x multiplied by half divided by 3x. So this means sine ACB is equals to 2x divided by 3x. So x and x gets cancelled out. All right. And therefore, we have shown that the value of sine ACB is 2 over 3 as per the requirement of the question. Okay, this was part A. So now let's move on to part B. It says that given that angle ACB is obtuse, okay, this angle ACB also looks obtuse to us, and the question is also saying this thing. So part B is saying that find the size of angle ABC, giving our answer in degrees correct to 2 dB. We need to find this angle ABC under the condition that ACB is an obtuse angle. All right. So here I'm going to do the working for part B. What we know the fact is that from part A we have shown sine ACB is equals to 2 over 3. But since angle ACB is obtuse, so first of all I'm going to find the inverse of this. I'm going to say that angle ACB is equals to sine inverse 2 over 3. So when you put this thing in your calculator, sine inverse 2 over 3, this will give you an acute angle, and then we are going to subtract it from 180 degrees in order to get the obtuse angle. So this one is 41.810 degrees. So we are going to say that this value is 41.810, but this angle is an acute angle, 41.810. Okay, but we need the obtuse angle. Since angle ACB is obtuse, so we are going to say that 180 degrees minus 41.810 degrees. So 180 minus 41.810 degrees, this is supposed to be 138.19, 138.19, or you can say 138.190 degrees. Okay, so here we have found the angle ACB, which is obtuse, but the requirement is to find the angle ABC. Okay, so since the sum of all angles in a triangle is equals to 180 degrees, so I'm going to say that therefore angle ABC is supposed to be 180 minus 138.19 and then minus 30 degrees. Okay, since the sum of all angles in a triangle is equals to 180, so 180 minus 138.19 minus 30 degrees, this is 11.81 degrees. Angle ABC is 11.81 degrees. Do we have any specific degree of accuracy? Yes, correct, to 2 dp. So ABC is 11.81 degrees. All right. Then moving on to the next part. In part C, it says that given further that the area of triangle ABC is 20. Okay, and find the value of x correct to 2 decimal places. All right. So I'm going to bring the picture of the question on the next page. So far what we know the fact is that this angle ACB, which is an obtuse angle, is 138.19 degrees. 138.19 degrees. All right. And this angle ABC is 11.81 degrees. Okay, so the area of triangle is given to us. So what we can do is that simply use the sine rule formula for area of triangle. Okay, so according to the sketch, I can say that the area of triangle is supposed to be half multiplied by the length of AB multiplied by the length of BC multiplied by sine ABC, because ABC is the included angle. All right, so 20 is equals to half multiplied by 4x times 3x multiplied by sine 11.81 degrees. यार ये लिखने में बहुत प्रॉब्लम कर रहा है. Sine 11.81 degrees. Okay, so I can say that 20 multiplied by 2 divided by sine 11.81 times 12, because 4 times 3 is 12. This is equals to x square. So the value of x square is supposed to be, just put this thing in your calculator. All right, 20 times 2 divided by 12 sine 11.81. So x square is 16.2 2866 and so on. All right, so I'm going to choose, so I'm going to take 16.287. X square is equals to 16.287. So therefore, x is under root of 16.287. So under root of 16.287, this is supposed to be 4.035. So 4.0357 I can take if I'm going to use this further in my calculation. So I'm going to pick up this value 4.0357, but the requirement is correct to 2 dB. Therefore, x is equals to 4.04. All right, first you write the higher accurate value correct to 4 to 5 SF. Okay, and then you write your answer correct to the specified accuracy of the question, or otherwise 3 SF if no specific degree of accuracy is mentioned. But in your further calculations, you should use the higher accurate value in order to avoid the premature approximation. So therefore, x is equals to 4.04. Correct to 2 dp. This is your answer to part C. All right. So now let's move on to the last part. And in part D, it says that find the length, find the length of the side AC correct to 2 dp. All right. So we need to find the length of this side AC over here. So we can do many things over here. Okay. If I use the cosine rule, so I'll be having the formula AC square is equals to AB square plus BC square minus 2 times AB times BC multiplied by cos 11.81, in which I'm going to use the value of X, which is 4.0357, to a higher degree of accuracy. All right. Alternatively, I can use sine rule as well. Sine 30 divided by 3x is equals to sine 11.81 divided by AC. So whatever feels comfortable, you can do it in that way. All right. So the most important thing is that whatever comes to your mind first, okay, so you just do it that way in the exam. No need to waste time on thinking much. All right. So I can say that sine 11.81, I'm going to use a sine rule over here, okay? Sine 11.81 divided by AC is equals to sine 30 degrees divided by 3x. Or I can use sine 138.19 divided by 4x as well, okay? So that's perfectly fine. So what I am going to do over here is that I'm just going to solve this. So AC length is equals to 3x multiplied by sine 11.81 degrees divided by sine 30, and I'm going to use the value of x which I found in part C. So AC is equals to 3 times 4.0357. I'm using this value of x to a higher degree of accuracy, as I've repeatedly mentioned earlier as well. So 3 times 4.0357 multiplied by sine 11.81 divided by sine 30 degrees. So just put this thing in your calculator. 3 multiplied by 4.0357 multiplied by sine 11.81. Okay. And then divided by sine 30. So this turns out to be 4.956. The length of AC is 4.956. All right. And correct to 2 dp, we need to give our answer. Therefore, the length of AC is 4.96. Okay. No specific units are mentioned, meter or kilometer, whatever. So just write your answer like this. This value is correct to 2 dp. So this was the requirement of part D. All right. Alternatively, what you can do is you can use the area as well, which is given to you. Area is 20, and this length BC you will use 3x and this AC will remain unknown. And the included angle is 138.19, which is the obtuse angle. And then accordingly, you can find the length of AC. So whatever comes first to your mind, whatever feels more effective to you, as quickly as possible, you need to gain your full marks and move on to the next questions in your paper. All right, so this was question number 13 of this handout, October 2019, C12 question number 7, and this is the last question of this video. I'll be uploading more videos, so stay tuned to my channel. Thanks for watching. Take care. Until next time. Assalamu alaikum.